Okay, we welcome to a new set of problems. We are going to solve these 11 problems to practice. See carefully what we are going to do. Basically, we are going to apply the first fundamental theorem of calculus. What it says, the first fundamental theorem of calculus? It says like this. It says, let's say that you have the function f of x. Let's say that f of x is a function like this one. It's a constant function. Okay, what is the antiderivative of the function? The antiderivative of the function is the function whose derivative is f of x. And the antiderivative of the function, we call it g of x. And who is the antiderivative of the function? Is a function whose derivative is a constant function, so it will be a rectilinear function, because a rectilinear function has a slope constant. So if g of x is equal mx plus b, the derivative g prime of x equal m. So this is m. This is m. Okay, so what it say, the first fundamental theorem of calculus? It say, take one point x1. This is the x-axis. Take one point x2. See the area that is between x1 and x2. x1 and x2. x2 and x1. And the area is here. And the area is clearly m by x2 minus x1 is the area of the rectangle that is here. This is the area. Or the area is equal to the integral of f of x d dx from x equal x1 to x equal x2. What it say, the first fundamental theorem of calculus, it say this is equal, see the point x1, see the same point x1 that is here, put it here, so there is a value of g of x1. See the point x2, the same point x2, let's say here, and see g of x2. G of x2. G of x2. So let me continue the rectilinear line. Okay, so g of x2 is everything. So what it says that the area contained below the curve f of x is equal to the change in the antiderivative function, is equal to g of x2 minus g of x1. The area is exactly this. This is g of x1. Everything is g of x2. So the area is g of x2 minus g of x1. So it's this portion. This is g of x2 minus g of x1. What it says, don't bother to find the area below the curve, below this curve. Instead of finding the area, instead of trying to make the Riemann sum to find the area, don't make the Riemann sum. Look for the antiderivative. And the antiderivative will tell you what is the area. How? Between x1 and x2, the area will be g of x2 minus g of x1. And this is what we are going to practice. So we have the function 6x, and we want to find the area that is below the curve 6x. So our function f of x is 6x. So f of x is 6x. What is the area? The area below the curve 6 of x is is c of x is the function that does like this. It's a rectilinear line. When x equals 1, f of x equals 6. When x equals 2, f of x equals 12. And it say between 0 and 2, what is the area? So what is this area? This area. I can find this area. Let's go to find geometrically speaking. I see one triangle between 1 and 2. So the area should be 1/2. The base is 2. The base is 2 by the height is 12. 2 by 12. What I'm applying is that the area of a triangle is 1/2 the base by the height. So 2 divided by 2 is 1, so the area is 12 units. 12 units. We have found the area in a geometrical way. We can find the area now because it's a rectilinear line and there is a geometrical figure that we know the area. But if this function is not a rectilinear line and is a parabola or any other function is a sine of x, we cannot do this trick. But now we can do this trick. Let's go to check that now if we make the integral from 0 to 2 of 6x ddx, the value will be 12. Okay, let's go to do it. The integral of 6x ddx will be 6 times the integral from x equals 0 to x equals 2 of x ddx. What is the antiderivative of the function x? Is x squared divided by 2 plus c. And how I will do this? I will say, don't need the c, but anyway I wrote the c. So this is between x equals 0 and x equals 2. 6 divided by 2 is 3x squared plus c. And I need to evaluate this between x equals 0 and x equals 2. X equals 0 is a nice point to evaluate because it will be 0. So how do we evaluate? G of b, this is g, this is the antiderivative g of b, g of 2. So let's go to right. We found that g of x is 3x squared plus c. And we need to evaluate g of b or g of 2 minus g of a, g of 0. Let's go to evaluate. So this is equal. G of b, 2 squared plus c, minus g of a. G of a is 0 squared plus c. Now you see the c will cancel. So I have 2 squared is 4. 4 by 3 is 12. 12 plus c minus 0 plus c. The c will cancel. So it will be 12. So we found the answer, 12, the answer that we were looking. But we found the answer that we were looking doing the integral. The integral is more powerful. It's more powerful because it allows to find the area even if the curve is not a rectilinear line, even if the curve is a cosine of x or any shape. Okay, now we have the problem want to teach you that you can use integral with the variable t because the variable t of the variable x, they are mute variables. So you shouldn't be surprised if you see a t or a w because it's the same. It's the same thing, the integral of x ddx, that the integral of w ddw, or the integral of zeta dd zeta. The solution is here is x squared divided by 2 plus c, And the solution here is w squared plus divided by 2 plus c, and here the solution is theta squared divided by 2 plus c. Is a mute variable. Okay, let me erase this. So the function that I have now, I cannot use geometry because it's a function that is a square, so it's not a rectilinear line. So the function f of t is 2t minus 1 squared. Who will be g of t? Who will be the antiderivative of this function? The antiderivative of f of t is the function g of t such that when you make the derivative of g of t, you will obtain f of t. Who will be? Maybe this one will work. Let's go to do it in a formal way. The integral from 0 to 1. So from t equals 0 to t equals 1 of the function 2t minus 1 squared ddt equal the integral from t equals 0 to t equals 1. Now the square of a plus b squared is a squared, 2t squared, plus b squared, 1 squared, minus 2 times the first by the second, 2 times 2t by 1. And this by ddt. So what I have done is I have developed this square. So the integral will be the integral of 4t squared ddt between t equals 0 and t equals 1 plus the integral of 1 squared, which is 1 ddt, again between t equals 0 and t equals 1, plus the integral of 4t ddt, and again between t equals 0 and t equals 1. And what will be this integral? Will be 4t cubed divided by 3 plus c. I will not write the c. Plus. So, this problem, I leave you to do it. It's an easy problem. The integral, the antiderivative of 2t is 2t squared divided by 2. So it will be t squared. I don't know if I make an it's 2t minus 1 squared. You develop this term. You developed a plus b squared, a squared plus b squared minus 2 times. You develop, you do it, the integral. I think that you know how to do it. Evaluate the definite integral of a square of between x equal 1 and 4. So it looks difficult, this one, but indeed it's not difficult. It's the integral of u minus 2 divided by square root of u ddu. Remember that the variable u of x they are mute variable. So this is from u equal 1 to u equal 4. Now the x is changed by the u. So how we will do the antiderivative of this function? How we will do the definite integral from u equal 1? So we will do like this, the integral from u equal 1 to u equal 4 of u divided by square root of u minus the integral from u equal 1 to u equal 4 of 2 divided by square root of u ddu ddu. Let's go to do it. Equal. U divided by square root of u is the integral from u equal 1 to u equal 4. Now u is u raised to the power 1/2 multiplied by 1/2 divided by 1/2. So this will cancel. Okay, ddu. Plus the integral from u equal 1 to u equal 2. So I will plug in the 2 outside, and I will write the u like u minus 1/2 ddu. Perfect. And now I have equal. What is the integral from u equal 1 to u equal 4 of u 1 half plus 1 divided by 1 half plus 1 plus 2 times 1 minus 1 half plus 1, 1 half divided by 1 half. And this must be evaluated between u equal 1 and u equal 4. Let's go to evaluate this. So this is u raised to the power 3 half divided by 3 half or multiplied by 2/3 plus 2 times, now 2 divided by 1 half is 4, and multiply, the 4 multiply, a u raised to the power 1 half, evaluate between u equal 4 and u equal 1, it will be 4 1 half minus 1 1 half. So it will be 2/3. Oh, I didn't evaluate here, sorry. Let me evaluate here. So it will be 2/3 that multiply this. I have to evaluate between u equal 1 and u equal 4. So it will be 4 3 half minus 1 3 half plus 4 that multiply 4 1 half minus 1 1 half. Perfect. Let's go to do it now. It will be a square root of 4 here. The square root of 4 is 2. 2 raised to the power 3 is 8. So it will be 2/3. 8 minus 1. 8 minus 1 plus 4 times square root of 4 is 2 minus 1. 8 minus 1 is 7. 7 by 2 is 14. 14 divided by 3 plus 2 minus 1 is 1. 1 by 4 is 4. So this is the result. You check it, please, and you let me know if I made any mistake. So let's go to the next problem. Evaluate the definite integral of the absolute value of 2x minus 5. We need to draw this function from 0 to 5. So you see from 0 to 5, let's go to evaluate, to draw first this function, not to make mistakes. What is the key point here? When 2x minus 5 is 0, 2x minus 5 is 0 when 2x equal 5 or when x equal 5 divided by 2. 5 divided by 2 is 2.5. 1, 2, 3, and this is the point. At this point, the function is 0. From to the left of this point, from value like 1, 2 by 1 is 2, 2 minus 5 is negative, but the absolute value, 2 by 1 is 2, 2 minus 5 is minus 3, and the absolute value of minus 3 is 3. So at 1 is 3. At 1 is 3. What is the value at 2? At x equal 2 is 2 multiplied by 2 is 4. 4 minus 5 is minus 1. And the absolute value of minus 1 is 1. So at x equal 2 is 1. So the graph of the function is doing something like this. Okay. And the slope is 2. Minus 2 and 2. The slope here on this side is 2. And the slope here on this side is minus 2. Okay, no, not interested in this. Let me erase this. So it means that this point is the point 5 divided by 2. So if I want to evaluate the area, that is here, the area that is here, I need to do it in two parts. I need to find the area from 0 to 5 divided by 2 of the function of the absolute value of 2x minus 5. But the absolute value of 2x minus 5 is minus 2x plus 5. This is the function. This is 2x minus 5 ddx plus the integral 5 divided by 2 to 5 of 2x minus 5 when x is between 5 divided by 2, 2.5, and 5. 3, 4, and 5. So I want to find this area. It looks that the area will be 2 times the area of one piece for the symmetry. But let's go to calculate. So it will be, the function will be now 2x minus 5 by ddx. Let's go to calculate. Well, I think that if I calculate this one, I multiply by 2 will be the total area. So you do it completely. So I will do it only this part, this one part. But if I multiply by 2, I will obtain this other part. Okay, it will be the antiderivative of 2x minus 5 will be x squared minus 5x. And evaluate between 5 divided by 2 and 5 will be equal 5 squared minus 5 by 5 minus 5 divided by 2 squared minus 5 multiplied by 5 divided by 2. So what I have done is I found g of x, and I found g of 5 minus g of 5 divided by 2. Let's go to make the calculation. 5 squared is 25. 25 minus 25 is 0. 0 minus, wow. 5 divided by 2 is 25 divided by 4. 25 divided by 4 minus 25 divided by 2, which is equal to 25 divided by 2 minus 25 divided by 4, which is equal to 50 divided by 4 minus 25 divided by 4, which is equal to 25 divided by 4. And 25 divided by 4 is some 6 something, 6 point something. So the area will be 2 times, the total area between 0 and 5 will be 2 times 25 divided by 4. So as a result, the total area, I guess, is 2 times 25 divided by 4. Let me erase here. 2 times 25 divided by 4, and 2 divided by 4 is 1/2, so it will be 25 divided by 2, or 12.5, 12.5. So this is the total area. It's done. This problem is for you. You do like this. You find the antiderivative of this function, g of x, and once that you find the antiderivative of the function, you evaluate g of pi minus g of 0. And the result will be the answer. G of pi minus g of 0. Well, the antiderivative is x plus minus cosine of x. The derivative of cosine of x is minus sine of x with this minus. So g of 0 will be g of pi will be pi minus cosine of pi, or pi minus cosine of pi is minus 1, or pi plus 1. And g of 0 will be x0 minus cosine of 0. So it will be 0 minus 1. Cosine of 0 is 1. 0 minus 1 is minus 1. And g of pi minus g of 0, g of pi minus g of 0 will be pi plus 1 minus g of 0, minus 1. So it will be pi plus 2 is the area. The area below the curve of the function 1 plus sine of x is pi divided by 2. Sorry, pi plus 2. Okay, let's go to the next problem. Secant tangent. I think we did it in the quiz 0, this integral. So to evaluate this integral, 4 times secant theta tangent theta ddx, well, indeed, written in this form, this integral will be like this. But I know it's a mistake. It will be 4 times secant theta, tangent theta, I don't know what is theta, the integral of ddx. But I know this is a mistake. This is the x and this is the x. Okay, this is the integral that he wants. If it were the one that it was written, you can take out this, the secant theta and tangent theta for some theta, and the integral will be between minus pi divided by 3 and pi divided by 3, and the integral will be 4 times secant theta, which is for some theta, tangent theta, and the integral of will be theta evaluated between pi divided by 3 and minus pi divided by 3 will be 2 pi divided by 3. It will be pi divided by 3 minus pi divided by 3 will be 2 pi divided by 3. But this is not the problem. The problem that is asking, sorry about the mistake, the problem that is asking is to evaluate the integral of sine of x, tangent of x, ddx. But we know from the quiz 0 that the derivative of the secant of x is the reciprocal of the cosine of x. It's not the inverse, it's the reciprocal. The inverse of is different thing. Okay, secant of x is 1 divided by cosine of x. So the derivative of secant of x is the derivative of 1 divided by cosine of x. And the derivative of 1 divided by cosine of x is sine of x divided by cosine square of x, which can be written like sine of x divided by cosine of x. Oh, sorry, there is a mistake here. Is equal, let's go to erase here. Is sine of x divided by cosine square of x, which is equal sine of x divided by cosine of x multiplied by 1 divided by cosine of x, which is equal to tangent of x multiplied by secant of x. Now, yes, tangent of x is here, secant of x is here. So because I have secant of x, the integral that they are asking me is the integral of 4 times secant of x multiplied by tangent of x ddx, because they are asking me this integral, and I know that the antiderivative of sine x tangent of x is secant of x. I already found the integral. The integral is 4 times secant of x evaluated between minus pi of 3 and pi divided by 3. But this is easy to see that is 0, because it will be 4 times 1 divided by cosine of x, evaluate between minus pi divided by 3 and pi divided by 3. So it will be 4 times 1 divided by cosine of pi divided by 3 minus 1 divided by cosine of minus pi divided by 3. But cosine of pi divided by 3 is the same that cosine of minus pi divided by 3. Remember that cosine of pi divided by 3 is this side, okay? And cosine of minus pi divided by 3 is the same side. So this is pi divided by 3 and minus pi divided by 3 have the same cosine. So you make the difference of to the same thing, so this will be 0. Let's go to the next. So on this problem we have to find the area below the curve 5x squared plus 2 between x equals 0 and x equals 2. You can draw the parabola 5x squared plus 2. So if you draw the parabola, when x equals 0 is 2, 1 and 2, and the parabola will do like this. And between 0 and 2, there is an area, and it say find the area. So find the area means find the antiderivative. So we find the antiderivative of 5x squared plus 2 is 5x cubed divided by 3 plus 2x. This is the antiderivative of this function. Evaluate between 0 and 2. The result will be 52 divided by 3. Okay, let's go to find the area of the graph x cubed plus x between x equal to and y equals 0. It must be x equals 0. It must be x equals 0 here. Okay, when you say x equals 1, is this rectilinear line. It's a line where for all points is x equals 1. When you say x equals 5, is this line. This is the line. When you say y equals 1, what is the line 1 equals 1? The line 1 equals 1 is this line. It's the line that for all points y equals 1. If you say y equals 5, is this line. Is the line that for all points the y is equal 5. So it's the set of points where the y is 5. It's all this set of points. So I think here is a mistake. Okay. So the area is from x equals 0 to x equals 2. And the area is the antiderivative of this function, which is x4 divided by 4 plus x. The antiderivative is x squared divided by 2. If you make the calculation, it will be 6. Let's go to the next one. Find the value of c, guarantee the mean value theorem for integral for the function fx equal x cubed between 0 and 3. What it say the mean value theorem? The mean value theorem say like this. It exceeds f of c. So imagine you have the curve like this, the function like this. And you have 2 points, A and V. So there is f of B and there is f of A. So f of A is this, f of B is this. What the mean value theorem says exceeds at point f of c. So this point is f of A. This point is this one, f of c. Exceeds intermediate point, the average that we call f of b, and exceeds a point f of c. So it means that exceeds c here, such what the area between a and v is the integral of f of x v dx between x equal a and x equal v. So the area is the area below the curve. So this is the area. And what it said, the mean value theorem, it says is 6 f of c such that the area, let's go to draw this f of c, so here like this, okay, exceeds f of c, whose area, the area f of c of the rectangle f of c by v minus a. So it's v minus a, this, by f of c, this. So it's f of c by v minus a, The area that is here is the same area that is below the curve. So here you see there are an area, if you consider f of c, this rectilinear, this horizontal line f of c, you know here there is no area, but the total area of the rectangle is equal to the area below the curve. So this is what it says, the mean value theorem, that exceeds c such that f of c by v minus a is the total area between a and v. So the problem say, find the value c that guarantee for integral. If you evaluate this between 0 and 3, find f of c. Let's go to find f of c. So the integral from x equals 0 to x equals 3 of x cubed ddx is x to the 4 power divided by 4 minus, evaluate between 0 and 3, or 3 raised to the 4 power divided by 4. So this is the area. So the area is 3 by 3 is 9, 9 by 9, 81 divided by 4. And 81 divided by 4 should be equal f of c by b minus a. v minus a is from x equals 0 to x equals 3. v minus a is 3. So the equation that I have is that 81 divided by 4 is f of c multiplied by 3. Then f of c is 81 divided by 4 multiplied by 3, or 81 divided by 12. So f of c is equal to, so f of c is equal to what? F of c is equal to c cubed, because the function f of x is x cubed. So f of c is c cubed, and c cubed is 81 divided by 12. As a result, the number c between 0 and 3 is the cubic root of 81 divided by 12, which is, I don't know. I don't have time, but it's 1.88. For sure have to be between 0 and 3, 1.88. Okay, and the problem is done. Go to do the last one. The last one say, find the value c that guarantee the mean value theorem. I'm not going to do it, but it's done here, so please check it and let me know if you understand. Good luck.